In this example, we're asked to find the solution to a cubic inequality. Okay, I've got three factors here, x minus 5, x minus 1, and x minus 3. And taken together, this makes a cubic function, which is factored for us, thankfully. And we're asked to solve it using interval notation. So I'm going to use the algebraic method again. We're not going to graph this thing, although you could. You could go ahead and graph it and find all the places that are greater than 0. But I want to do it algebraically, and I'm going to use this number line that I've used in past examples. And I'm going to think about this in terms of x-intercepts. Where are the x-intercepts here? Well, there's one at 5, okay, there's one at 3, and there's one at 1. Those are all my three x-intercepts. The reason why x-intercepts are important is because when you're thinking about what the signs are doing in this function, right, let's say we've got a function here. I'm not going to plot the actual function above. Let's say that's my function. Where is my function changing its sign? Where is it going from positive to negative? Well, it's at these special places, the x-intercepts. Okay, so that's why I like having these x-intercepts on the sign array that I'm drawing here, because those are the important places. So I've got my x-intercepts, and now I put the factors up here. Doesn't really matter which order you do these in. Just get every factor over to the right, and you say for each factor, where is this factor positive and negative? So x minus 3, for example, is positive when you're above 5, is positive when you're between 3 and 5, and is negative at numbers lower than 3. X minus 1, whole bunch of positives here, but it's negative below 1. And x minus 5 is only positive when your numbers are greater than 5. Okay, so now you just multiply your way down, and you get a negative, a positive, a negative, and a positive. If you're not seeing how those numbers are happening, what I'm doing here is I'm saying a negative times a positive times a negative. The result is positive. Okay, that's how this is happening. Now, take a look back at the equation. What's it saying? It's saying the result is greater than or equal to 0. So where's my sign array? Positive. Greater than 0, right? Well, here's one. Right here, it's between 1 and 3. And I'm going to use square brackets because 1 and 3 themselves are equal to 0. And I'm allowing greater than or equal to 0. And then the other place is right here, from 5 to infinity. Okay, those all produce a positive result. And I need a union in between them. So that's my solution. And if you want, go ahead, plug any value in. If it's in this interval that I've just boxed in, you'll get a positive result for this polynomial. If it's not inside that interval that I just boxed in, you're going to get a negative result. And if it's on the edges, 1, 3, and 5, you're going to get a 0.